video is going to give you some guidance on how to do the worksheet on piecewise functions, mainly because these are a little bit different than the ones we went through with the examples in class. So I just wanted to give you guys some input on how to do those. So number 2 here is the first one that I'm going to do. You see we have g of x is equal to 2 pieces. The top piece is 2x plus 3 if x is less than or equal to 0. The bottom piece is 5 if x is greater than or equal to 0. Well, just based on my inequalities, this top piece is going to have a closed dot at the boundary line of 0, and the bottom piece is going to have an open dot. Now before, we would merely take our endpoints whenever x was sandwiched in between two values and plug them into the linear function, because again, this top piece is linear, to get the points. But we only have one endpoint here because x is open-ended. X is going to be everything that is less than or equal to 0. So you do want to plug in 0 as one of your points. So 2 times 0 plus 3 is going to give me 3. So 0, 3 as a closed dot is going to be the first point that I plot. To get another point to graph this line, I just need to pick some other x value that is within the boundary. So some other x that is less than 0. So we could use -1. If I plug in -1, 2 times -1 plus 3 would give me a +1, -2 plus 3. So -1, +1, that would be my second point. Then to graph those, I'm going to start at the boundary point and draw through. So that's going to be the top piece there, the 2x plus 3. Notice it stops at x equals 0 because that's where one function ends and the other one begins. Now for the other piece, this is merely 5. Well, 5 is like graphing the equation y equals 5. That's going to be a horizontal line that starts at x equals 0, but that is an open dot. So I would go up to 5 and put an open dot on that 0 line. It's going to equal everything greater than 0, so that line is going to be going off to the right. And that's what your graph would look like for number 2. So a lot of these questions are very similar. You can see number 1 has 2 horizontal pieces because your functions are -2 and 1, so those are both going to be horizontal. Number 3, those are both going to be diagonal pieces. Number 4, that's another one with 2 horizontal pieces. 5, you start getting into the 3 pieces. Notice that your middle piece for number 5 is sandwiched in between 2 x values, so those are the values you would use. Beginning and ending, they were horizontal. And then once you get into the second page, the top 2, number 7 actually throws in a quadratic. Remember, we went over that with the example that went along with the notes. For quadratics, you want to think about what your h and k values are and make sure that you use that vertex h and k value. And then for number 8, you have an absolute value. So you want to make sure that you get enough in there to get a good representation of what your picture is going to look like. So the other question I'm going to work out is number 9. Number 9, you were given the graph, and you need to come up with the equation. So the first thing you want to do is you want to figure out where your boundaries are. This has one boundary because there's only 2 pieces, and the x value where the boundaries occur is -2. So typically, the left-hand piece is going to go on the top, and the right-hand piece is going to go on the bottom. The left-hand piece is going to stop at -2, and it is an open dot. So the top piece is where x is less than -2. The bottom piece is where x is greater than or equal to -2. My calibration is a little bit off, so just hopefully that won't bother. It won't be too terrible for the rest of this problem. So again, back to the left piece. If I count my slope of this left piece, I'm rising 1, running 1. So that's going to give me a slope of 1. So this equation is just going to be an x. It doesn't actually cross the y-axis, but if I were to keep counting, it looks like it would cross at 2. So I have x plus 2 as my equation there. For the right-hand piece, again, I'm rising 1, running 1. So that is also going to be a slope of 1. So 1x or just x. And this one does cross the y-axis at -3. So that's going to be the equation x minus 3. So that would be your solution. That's what you would type in for your equation. I hope this was helpful. I know that sometimes these problems can be difficult, especially when you first start working on them. And just note that for number 9, your boundaries are not always going to be the same value. If you look at number 10, the left piece stops at a different number than the right piece starts at. So you're actually going to have a gap in number 10 between your values for your domain of x. So just be aware that can happen. Contact me if you have any questions, and good luck on graphing and writing equations of piecewise functions.